All right, hey guys. So we are going to move on now. You have learned about quadrilaterals, you've looked at the different ways to classify them, and the question is, how does this really relate to what we're doing? And what we're doing is proving shapes on the coordinate plane. So what we're going to be doing is using our knowledge of how to find, lengths using the distance formula, or determining if lines are parallel or perpendicular using their slopes. We're going to use that to actually help us classify what type of shape we are looking at. Sometimes it might tell us beforehand what shape it is, and you might need to follow these steps to be like, I can say with complete confidence, this is the shape that I have. Other times, it might not even tell you what shape it has, and you might have to use these steps to determine it. So I do want to start off by saying there are actually multiple different ways to go about determining and classifying your quadrilaterals because there are so many different characteristics. However, what I've come up with for you here is a surefire way to always correctly classify your quadrilateral and to make sure that you're using all of the information. So we need to make sure by the end of the day or by the end of your problem that there is no holes in your argument. I can't poke your argument and say, well, you never actually showed that they're perpendicular, so how do you know it's not blank shape? So this is what I'm going to step you through. Before I really look hard at this flowchart, I'm actually going to come up here to some of the shapes, some of the symbols. So you might have seen these in the other parts of your lessons so far, but I want to talk about just some basic geometry symbols. We've already looked at the fact that two parallel lines means that it's parallel. Conversely, you're going to see for each of these, if you take a symbol and you throw a dash through it, that means that it's not that. So say that I had the slopes 2/3 and 5/3. Obviously, those are not the same, so I would say they are not parallel. I could go ahead and throw that symbol in there. Also, these are not perpendicular, so maybe if that's what I was trying to find, I could say, nope, these are not perpendicular. So you might see some of those symbols along the way. Some of the new ways I want to show is that if you're given a shape and you see these arrows, that means that they're saying they are parallel. Now, because each of these have one arrow, that means this line and this line are parallel. These are classified differently. They both have arrows pointing in the same direction, but these have two. So it's saying this line and this line are parallel. We can tell by looking at this that these lines, the adjacent means side by side, are not parallel. But by differentiating one arrow and two arrows, that's saying these two are parallel and then these two are parallel. For perpendicular, well, we know that perpendicular really means that they meet at a 90-degree angle. So the way that we show that on a shape is actually by putting in the right triangle, or sorry, the right angle, the little square that denotes that this is a 90-degree angle. So these two lines are perpendicular, these two lines are perpendicular, these two lines are perpendicular. The next one that you may not have seen in a while is this symbol. It means congruent, which means that they are the same length. So if you wanted to add that, congruent means that they are the same length. And notice it really looks like an equal sign with this little squiggly on top. The way that we show that on our shapes is by drawing dashes on them. So this one, because they all have one dash, means that all four of these lines are the same length. Over here, these two have one dash, which means they are the same length. These ones have two dashes, which means these two are the same length. So just to show you those geometry symbols. So going back to our quadrilaterals and how we are going to organize them here. Like I said, there are other methods, but this is the method that is going to give you the most direct path to make sure that you know what type of shape you're looking at. So one of the first things that we noticed when you're looking at your different ones is that it's based on how many sides are parallel. So over here, this big category are our parallelograms. So this big category over here, once again, these are the parallelograms. And what that means is that both sets of opposite sides are parallel. If it is, it's a parallelogram. If only one set is parallel, then we're in the world of a trapezoid. So if only one set of opposite lines are parallel, it means we're in the world of a trapezoid. Versus if none of them are going to be parallel, then we're in the world of just either a kite or a basic quadrilateral. Now, you guys may have seen on some of the things that trapezoids are sometimes considered Parallelograms, for our sake, we're going to split them into these three different categories based on, once again, are the opposite sides parallel? That's where we're always, always, always going to start. When I say opposite sides, I do want to clarify that. This and this would be considered opposite sides because they're on opposite sides of the shape. Furthermore, this side and this side would also be considered opposites because they are also on opposite sides. So if both the green lines are parallel and the yellow lines are parallel, we know it is a type of parallelogram. For an isosceles, for a trapezoid, we know that one set is going to be parallel, the other set is not. So the ones I highlighted in green are parallel, these are not. These are not. That gives us a trapezoid. And then our world of a kite versus a quadrilateral, none of these are parallel to anyone else. So these two are not parallel, these two are not parallel. These two are not parallel, these two are not parallel. Then we know we're in the world of a kite. So that is always, always, always going to be your first step. So both sets, you have a parallelogram, you're looking for one of these four shapes. One set is a trapezoid, you're looking for either a trapezoid or an isosceles. None of them are parallel, you're over here. We're going to zoom in on the parallelograms for a second. So we have already determined that both sets of opposite sides are parallel. Then the next question that actually distinguishes them, the difference between a rectangle and a parallelogram, or the difference between a square and a rhombus, has to do with the angles. Squares and rectangles have angles that are 90 degrees. Rhombuses and parallelograms, their angles are not 90 degrees. So that is your next question. Are they 90 degrees? When it says use slope here, we're asking a question, are they perpendicular? Are they perpendicular or not? If they are perpendicular, you're going to go into the category of either a square or a rectangle. If they are not perpendicular, so these ones would be perpendicular, these ones would be not perpendicular, then you're going to be in the world of either a rhombus or a parallelogram. So that's our next classification. And we've already calculated the slope, so you just need to compare them. Then we're going to ask ourselves, well, what's really the difference between a square and a rectangle? Or what's really the difference between a rhombus and a parallelogram? And that has to do with the lengths of the sides. We know that squares and rhombi are really, really special because all four are the same length. Versus a rectangle, these two are the same length, these are the same two. Same with the parallelogram. These two are the same length, these are the same length. So in order to determine that, we use the distance formula. To be super careful right now, we are going to find it for all four sides. Always, always, always just go ahead and find it for all four sides. And if all four of them are congruent, cool, you get a square. Or over here, if all four are congruent, cool, you got a rhombus. If all four are not congruent, so if these two are the same and these two are the same, then you have a rectangle, if you're in the world of perpendicular. So notice how you can follow this here. We're always going to start with the question, are the opposite sides parallel? If we find out that both of them are, we know we have a type of parallelogram. The next big question, we've already found slope as well. Is it a square, rectangle, or rhombus parallelogram? That has to do with, are they 90 degrees or not? Then, after that, you're going to determine the lengths of them to determine, is it a square versus a rectangle or a rhombus versus a parallelogram? All right, so those are our parallelograms. In the middle here, we have the trapezoids. So once again, the trapezoids, we still start with that first question, are opposite sides parallel? If we found out that one set of opposite sides, so if we found from this length and this one, this leg and this leg, if they are the same slope, but these two do not have the same slope, we have a type of trapezoid. The only classification we can go further is what is known as an isosceles trapezoid. An isosceles trapezoid is special because these are known as the legs, the non-parallel sides. So these are the parallel ones. The non-parallel sides are known as the legs. If they are congruent, then it's known as an isosceles trapezoid. So after we've determined that there's only one set of parallel lines, the next thing we're just going to do is calculate, well, what about the length of the legs? If they're the same, awesome, it's an isosceles. They're not the same, cool, it's just a normal trapezoid. So less classification here to get between the two. One side is parallel. Awesome, cool. Well, then what about the lengths of the legs? If the lengths of the legs are the same, you have an isosceles. The lengths of the legs are not the same, a trapezoid. Last but not least, then, are our other two ones here. These are the ones that had no parallel lines. They have no parallel lines, then the only options are just a basic quadrilateral. This is as general as you can get. It doesn't have anything special about it. Or this idea of a kite. A kite is actually really cool because the adjacent or consecutive sides are the same length. So I'm going to highlight here. These two would be the same length. And then, let's use blue. These two would also be the same length. That's what's going to be considered a kite. So if you've determined that there are no parallel lines, and you want to come over here and you want to find the lengths of all four. We call these either consecutive sides or adjacent sides because adjacent just means next to it. So this is what we would have here. So when we really start proving these are the steps you're going to go. You need to be thinking about what is enough information to show that I'm confident in the shape that I have. So the biggest thing we're going to do is how many sets of parallel lines are there? If there's no sets of parallel lines, you're over here, one set of parallel lines or two set of parallel lines. And yeah, that's really where we are going to be going from here on out.